Now let's do this question. Is most stone removed with the same row of column? So you can see it's a medium level question. And then also this question is today challenge. And we can see there, okay, so many company asked this question recently. Okay. And there is a acceptance rate is 61%. Okay. So now how to solve this question? Now we come to here. I just pin the first example here, and then the output is 5. Okay, the output is 5. So how do we know the output is 5? So actually in this question we need to generate a diagram first, and then we need to count the correction between each stones. So let's see. We know this stone have relation with this stone, right? And this stone have relation with this stone, and this stone have relation with this stone, right? And then this stone have a relation with this stone, right? And then here also have, you can see we cover all the stone in our the diagram, right? So actually we can count there only one collection, and then you can see the length is 6, right? So the question is we need to count the collection, how many collection we have. So now we know only one collection, because, and then you can see the length of the stone array is 6 minus 1 equal to 5. So we just use this formula to solve this question. And then now let me just walk you through the logic first. Here, 1 second. Because the question say we can a stone can be removed if it share either in the same row or same column, right? So because we know these two, oh, 1 second. Oh, okay. Because we know these two stones in the same row, right? So we need to remove one. So let's count how many stones we have to remove in the diagram. So now we remove this one because they have two stones in first row, right? Now we count one because we already removed one stone. And then we know this stone and this, and with this stone in the same column. So now we remove either one. So we remove this one. So now here plus one, and then now we know these two stones have in the same row, right? We can remove either one. So maybe in this one. After here, we just plus one because we remove one more stone in the diagram. Then you can see here these two have the relationship, right? We are in the same column. So now we remove the one. Okay, now we can see here they have these two stones left, but they're in the same row, right? So now we remove the one. So now there only one stone left, right? So how many stone we remove? 5, right? So just like I mentioned here, we need to count the collection between all the stone. We need to find the stone has relationship with other stone or not. If yes, we can keep going down, find all the relationship between uh, those stones, and then we just the length, the number of stone minus the collection, and then we got the final result. And then here we need to create the diagram here. So the diagram can see 1 second. Let me remove here. So I'm not sure. Do you familiar with the building the graph? Yeah, we need to building a graph, and then we can find all the relationship where is the stone ready to. So we know here have the stone. Maybe make simple. Stone is stone. Is here also stone. 1, 2 stone here. So you can see for the current stone, this stone have ready to this one and then this one. So we need to provide the 0 with the 1 and the 2. What is the 0 mean? 0 mean is the partition, or I would say is the index in the input array, in the stone array. So we know 0 with 0 in the first partition, right? It's 0. And then we can see in the diagram, we know, oh, 1 second. We know this stone have, with this stone in the same row and column, right? So now we need to provide these two stones partition here using the linked list or array list is up to you. And then do the same thing here, here, here. We just need to build the diagram, and after that, we need to use the set over the array is up to you, because we make sure if we already weighted the stone, we cannot weight the same stone 2 times, right? Only 1 time. So now set can easily to help us to keep track of the status of each stone, or you can use the Boolean array to keep track of each state of, right? So now let's start coding this one. Now first we need to get the length of stone. Now we need to create an array. We can call this one is graph. Now, how many the graph here, how many row and column here is up to the n, how many stone in the graph. So now it's I to 0, then how many lists we have depending on the n, right? So now after here, we need to make a collection between 2 stones or more than 2 stones. Now here we need to check these 2 stones have relationship or not. To make sure these 2 stones in either column or row, right? We here say same row or same column. Make sure that, so that's what we need to make 2 stones connect, right? So here we need to check, and we need to pass the stone I with the stone J. If yes, if these 2 stones have either same row or same column, and then we can say we need to create a graph, get I and add J, add I. Now we need to complete this one. We can create here is Boolean A, yeah, B, right? So we need return A equal to B over A, and this one is checking the row, right? And here the one is mean check the column for both stones. If either one satisfy, okay, would you say these 2 stones have the relationship? Here check. Right now here, after we finish here, so we need to create a boolean, an array, or I would say a vector. And now we need to go look through the star array one more time. And we also need to create a collection. So how many collection we have? Now here, if vector I not equal to, not equal is not true, right? So which means the current stone still not be vector, so we can remove it or vector it. Now we need to call the function, df function. So we need to pass the boolean array and the graph and the I, and we need to create collection. So here, so we need to n minus collection. So now we need to implement the df function. It is void df is boolean, right? Boolean array. And the list is in the graph. And then we need to pass the current index. So now here should be current index equal to 2, which means we already vectored the stone. Now we need to pass the in label of get current index. Okay, if not with the current index, so now which means we need to keep call the df function, right? No, I think I complete this run it. Oh, okay. The problem is connection. Oh, it's not. Oh, sorry, it's not current index. It's label. You can see it's passed on the test case. Oh, then it's run it. Okay. So now I would say the time complexity is n squared, because you can see, because here I just build the graph, right? The graph take n squared time. So now the space complexity is, because here you can see we create also n squared, because you can see in the graph use the one list inside another list, right? So the space complexity is b of n squared. And then thank you for watching this video.